where B1 by B is greater than 5, then load carrying capacity decreasing, and at the point B1 by B is equal to 0.5, the pressure is maximum. Effect of sigma, the load carrying capacity increases. Effect on load carrying capacity with respect to H2, the load carrying capacity decreasing with various parameter. It is conclusion of this problem. Only standard deviation under only standard deviation improve the load carrying capacity, unlike the case of transverse roughness. So while making the bearing, we consider the standard deviation and other parameters. Next problem, the study of longitudinal surface roughness on hydrostatic circular footstep bearing. Here we analyze the behavior of longitudinal surface roughness in hydrostatic circular footstep bearing. Here the slip velocity on the is modeled by Joseph and Bevier. Roughness effect has been studied by statistical model, and we get pressure and load carrying capacity, and the result are presented graphically. Here the bearing geometry. Here R0 is the radius and inner radius is R1. Here we give the pressure PS. Here the flow rate Q. This is governing Reynolds equation. This is the fluid film thickness, and statistical averaging process of equation 1, we get Q flow rate, and the here S is the quantity. Using boundary condition, we solve this equation. We solve the differential equation dp by dr. Using the boundary condition, we get pressure P. And with the help of boundary condition, P is equal to PS, we externally add the pressure PS. R is equal to R1. We get the pressure P is equal to PS log R0 upon R log R0 upon R1. And now using non-dimensional quantities, this we get the non-dimensional pressure P. P is directionally proportional to flow rate Q. And now integrating this pressure, we get the dimensionless load carrying capacity. Here the dimensionless pressure and dimensionless load carrying here the dimensionless load carrying capacity. Here the value of S. Now calculate this, we get the load carrying capacity, which is represented as a graphically effect of sigma on load carrying capacity increases for various parameter. alpha star, epsilon star, slip velocity, inner radius. The standard the load carrying capacity increases. Here the effect of alpha for various parameter. The load carrying capacity decreases. For slip velocity, also the load carrying capacity decreases. Here, the performance of here conclusion is the load carrying capacity increases only effect of sigma star. We can minimize the load carrying capacity using the slip velocity and while designing the bearing, the roughness must be addressed suitably if the slip is less. In the longitudinal surface, roughness is better as compared to transverse roughness. Next problem. The study of longitudinal surface roughness on the performance of hydromagnetic slip field in infinitely long rectangular plate. Here we study the longitudinal surface roughness on the hydrodynamic slip field in infinitely long rectangular plate. We use the statistical method of Christensen and Tonder for longitudinal surface roughness. And to obtain the expression of pressure distribution, we use the statistical averaged Reynolds type equation, solve with suitable boundary condition. Then it is used to get the load carrying capacity. Here the being geometry. Here the bearing geometry. Geometry of Swiss field bearing with rectangular place is presented here. Here upper surface is fixed and lower surface moving with velocity u in the x direction. And bearing surface are assumed to be longitudinal rough. Here the film thickness and the governing Reynolds equation for film pressure P is here. Assuming infinite length in x direction, equation takes the form this s cube d2 d square upon d z square into p minus mu 0 mu bar s square by 2 is equal to 12 mu s dot. Now under the usual assumptions and applying averaging process, the pressure governing Reynolds equation takes the form this s square is equal to kb square into this. Here mu 0 is the magnetic susceptibility and mu bar is a free space permeability and mu is lubricant viscosity. Now integrating this, we get this For pressure, again we integrating. We get this equation with respect to Z. Now using associate boundary condition, Z is equal to plus or minus V by 2. Then pressure P is equal to 0. Using this boundary condition, we get the pressure P. Now we introducing boundaryless quantity. We get the dimensionless pressure. Now integrating pressure with respect to Z star, we get a non-dimensional load carrying capacity. Now we calculating this. Effect of load carrying capacity for mu star magnetic fluid. The load carrying capacity increasing for mu star for various parameter sigma star, alpha star, epsilon star. Now the effect of standard deviation on mu star, alpha star and sigma star. Load carrying capacity increases. Here for effect of alpha star, load carrying capacity decreases. It can conclude from the graphical data. Magnetization and standard deviation cancel out the adverse effect of variance and skewness on the performance of bearing system. So we can consider this while designing bearing for suitable magnetic strength in the presence. Next problem. Study of longitudinal surface roughness on the performance of infinitely short journal bearing. To study the performance of an infinitely short rough journal bearing, the effect of longitudinal surface roughness on the system has been extracted using the Christensen and Tonder model. Now corresponding Reynolds equation has been solved using boundary condition. We get pressure and then it is pressure is used to get the load carrying capacity. Here after calculating this data, we get calculate and the result, we get the result and it is presented as a graphically. Here the geometry of short bearing, here the pressure distribution, and we use here hydrodynamic lubricant theory. And this is general bearing. The pressure governing equation is the Reynolds equation in 2-dimensional. For incompressible fluid, we get this. We have this equation, and for short bearing, for infinitely short journal bearing, dp by dx is equal to 0. So this part becomes 0. So for short bearing, the Reynolds equation for short bearing is this del by del z as cube del P by del Z is equal to 6 mu U dH by dx. The bearing surface are assumed to be longitudinal rough. For Christensen and Tonder used this film thickness h is equal to s bar s plus delta s. Here the mean film thickness delta s is the random deviation, and here we use the probability density function for film thickness from the Andaria et al. According to stochastic averaging method for longitudinal roughness discussed in Christensen Tonder, Andaria et al. And this transform to this. This is the averaging process for film thickness. Now take x is equal to r theta, derivative dx is equal to r d theta, and here height in the journal bearing h, film thickness h is equal to c plus e cos theta, and now derivative with respect to theta we get this, and eccentricity e for dimensionless e by c. Fluid film thickness h bar is not function of z, so hence this equation becomes d square p by dz square is equal to this. Putting this value here, x, integrating this above this equation twice with respect to z, we get the pressure and now using the boundary condition at pressure 0 and z is equal to 0, dp by dz is equal to 0. Using this boundary condition, we get the pressure. Now, introducing dimensionless quantity in this equation, we get non-dimensional pressure. And for this load carrying capacity is W is equal to the direction of the line of central is denoted by Wn, and the line center direction of line of total force component Wt and Wn, Wn square plus Wt square, and for general bearing we get W star load carrying capacity. Here the calculation is some difficult, so we use the Simpson 1/3 rule for this. Now using Simpson 1/3, we calculate this pressure with respect to effect on pressure distribution with respect to theta angle. In general bearing, we sense the theta, we get the different types of pressure. Here increasing the pressure at that point, at this point, the pressure maximum, then pressure is decreasing. And for Z star, the pressure is strictly decreasing. And effect of sigma star on load carrying capacity is increasing. Also, eccentricity, the effect of eccentricity on the load carrying capacity is also increasing. This study emphasizes that the roughness aspect must be evaluated when designing this type of bearing system, which is important from the bearing life. It is observed that the standard deviation and eccentricity greatly improve the load carrying capacity. In general conclusion, for longitudinal surface roughness, the standard deviation, uh, the standard deviation and magnetization improve the load carrying capacity, and this is the references. Thank you.
If you have any clarification to sir, please post it in the chat box.
Any questions?
No questions for now, sir. Let us wind up the session, sir. On behalf of the Department of Mathematics, PG and Research Department of Mathematics, Jamal Mohammed College, Tiruchirappalli, I thank sir for giving such a wonderful presentation on the topic, on a new topic, tribology. Maybe all the participants will be new to this topic. Thank you, sir, for your insights and your
Thank you,
valuable
sir.
time. Thank you. Dear participants, I request now the feedback link will be posted in the chat box. It will be available only for 15 minutes. I also thank all the participants for the patience and attending this session. Dear participants, there will be no meeting tomorrow. The next meeting will be on 8th of February and the time will be 3 o'clock.